So let's tell the people exactly kind of what we're talking about. Because as I understand it, okay, I'm kind of new to this and what you're working on, but it's like, right, just based on the website name, alternative propulsion, right? So other
Yeah.
propulsion systems, you mentioned anti-gravity. What
Yeah.
are some of these
Well,
things
there's
that
been
you're,
tons of people over the years, like Stephen Greer, Michael Schratt, even Philip Corso, a number of people who over the years have said, yeah, that they've got anti-gravity craft, that these things are flying saucers. So is that possible? Did they figure it out? So
but
we
what does
we
that mean exactly? Like when I hear
Yeah, I
anti-gravity, what
know.
what
That's
do
like
you
a
mean by
misnomer.
that?
And a lot of scientists, it's like a turnoff term, like cold fusion. It's like, well, you can't have, fusion without, some kind of action. But, then they realize that temperature on the quantum scale is different than temperature as we think about it on in stars and large scale
Yeah.
dynamic systems. So there's ways, there's even negative temperature on the quantum level. So there's a whole different interpretation of what temperature is. So the whole idea of cold fusion is on a lattice-assisted nuclear reaction is a much better term, which is the term more commonly used now for it. But that's
Wait,
considered pseudoscience.
that's the better term to use. I didn't even understand what you just said. I don't know if that's
Yeah,
the like there needs to be a better PR term than lattice something. I don't know
yeah,
what you
it's
just
called
said.
LANR or LANR, lattice-assisted nuclear reaction or low energy nuclear reaction. So a lattice-assisted means that it's basically the lattice of the palladium metal, and then they put
Okay, okay.
palladium metal in this heavy water, which is it's like deuterium oxide instead of H2O, it's D2O, and it's like hydrogen with an extra neutron. So it's a little bit heavier. Still get the same
I've
charge.
heard of this on Brian Keating's show one time.
Yeah.
I heard him talk
And
about
then
that.
all that goes is forced in electrolytically, it's forced into that cathode until you get like 80 or 90% loading. And then once it's loaded to that 90% saturation level, the particles become so like close to each other and packed that they actually quantum tunnel past the Coulomb barrier. So you have fusion without that Coulomb barrier. That's how it breaks the Coulomb barrier, by packing them all tightly enough in the lattice. And then they found it's even better when you put these waves across the lattice, called
What's the
super
colon barrier? What does that mean?
Coulomb. So
Coulomb.
Coulomb is the force of repulsion between electric charges. So like the electric charge of the nucleus is positive one, and the electric charge of the electron is negative one, and then the
Okay.
force between those is equal to this Coulomb force, which is F sub c, Coulomb constant times the two sum of the charges divided by the square of the radius between them. But it's so the distance apart, is the closer they get together, the higher the force is, and the further apart, the lower the force is. Kind of like magnets, you bring them close together,
Okay.
they get.
Got it. Okay.
So the Coulomb
And so
force
what so oh
is
sorry, go ahead.
this. So
Please.
the in two atoms, you have the electrons in the outer clouds repel each other because they're both negative. So if you try to move the atoms closer to each other, that exterior shell kind of prevents you from pushing the atoms together and creating spontaneous fusion. It's kind of like an eggshell that needs to be broken, and so
Got it.
that's the Coulomb barrier. So you need to
Got
break the
it.
Coulomb barrier in order to get those two nuclei to get past that distance, and then the strong force takes over through quantum action. And so there's a way to cheat quantum particles into doing this inside of metal lattices like palladium lattices, and using these waves. And there's this model of called the hydroton model, where you have strings of these deuterium atoms which actually bump together and bump against each other in these and form these wave-like pattern strings inside the material. And at those nodal points is where the fusion will sometimes occur spontaneously, where it gets, if you got to slam from both sides, it works the most efficiently, and you get this sort of peak in the middle, and that peak will create fusion. And then the fusion, rather than being distributed as a photon, because normally when you fuse two things together, it creates a ton of energy, and that energy is released. And it actually releases gamma rays, according to the equations,
Okay.
which is what the skeptics like Hozienga and others have said. Oh, well, this no way you can have created fusion, because Pons and Fleischmann would have been killed in their laboratory, the two scientists who discovered it in the 80s, and
Yeah, from
caused
the
that.
gamma rays.
They said the gamma rays would have killed them in the laboratory,
Yeah.
So where are the gammas if you really created fusion? So it's
Sure.
impossible.
Okay.
So these scientists at MIT, Hagelstein, Peter Hagelstein, I have a bunch of videos. I went and interviewed them, and went to lectures and filmed the lectures and stuff, going into all this stuff years ago for people that really want to dive deep on all the physics of it and the science of it. But I believe that they're using, seawater has deuterium in it. It has a small amount of deuterium, and even hydrogen might be possible with higher energy systems and better materials. You might be able to get fusion with just regular hydrogen. Um, the sun uses hydrogen. That's where all of our power comes from on Earth. All even our fossil fuels is stored solar energy from suns thousands and millions of years ago,
Yeah.
supposedly, according to the main predominant theory. So yeah, you have sun and hydrogen. I think that this is, have lots of UFO reports of UFOs going into beds of water and staying there
Yeah.
for periods of time before, resurfacing and leaving. Shag Harbor incident in Nova Scotia. There's a number of places like Puerto Rican Trench off the coast of Puerto Rico. There's a place off the coast of Catalina Island where a number of sightings. So they have sightings of these UFOs going in and out of the water. Could they be potentially harvesting the deuterium or seawater and using that to fuel their ships? Because you could potentially distill all that seawater out and then use that as fuel through cold fusion quite effectively. It seems plausible. And then also these
It's interesting.
the idea about, back to the whole idea of these gammas or why they're not created gammas, is that Hagelstein, the MIT scientist, came up with this theory that it's actually distributed to the lattice as a phonon, rather than a photon, which a photon is a vibration in the electromagnetic wave, the electromagnetic field, whereas a phonon is a vibration in the lattice structure of that metal. So like the atoms of the metal essentially absorb
Got it.
that
So you don't
energy.
feel anything like a bulletproof vest, like Kevlar of some sort,
Yeah, and it's
maybe.
also, it does weird transmutation effects to the metals too. Like you get the metal will start turning into, it will gain a proton, or sometimes like because this chain reaction will go off, and particles just start going flying everywhere, and then they stick to other things, and weird stuff starts happening on the quantum scale when you get to real high energy levels.
Yeah. Well, that's interesting. So they proved that basically they wouldn't have died from gamma rays, is what you're saying.
Yeah, well, he didn't prove that they wouldn't have died of gamma rays. Rather, he offers an alternative explanation for why they didn't die of gamma rays.
Okay, I see. I
So
see. Yeah.
um,
And so is Cold Fleet, is this something that you and
and
your
then,
team have been working on for propulsion, cold
well, no, that's
fusion?
the energy part. So once you have
Okay.
energy, propulsion is not a problem. I mean, you can. They basically said, we don't. When they were creating the F-117, with all those flat sides to make it stealth,
Yeah.
stealth, they has all those flat panels in it. They basically said, you give it enough propulsion, we can make a refrigerator fly. So they don't care about that. And if you have enough energy, you don't care about the propulsion system, because you can just direct the energy the right place, and you have propulsion. So yeah, I think energy is actually the bigger problem than the propulsion itself, even though both
But
of them are.
also harnessing that energy, right? Because you can't just, what mechanism it comes out of, and the body, if somebody's in it, like how to protect them, how to protect the structure,
Yeah, the
right? Because
shielding. Yeah.
otherwise, it's like the atom bomb, right? Okay, you figured out we can smash atoms, I mean, I'm sure
That's
I'm getting
interesting. The
that right,
shielding thing
but
came
how do
up
you come up
today.
with the mechanism for it, right? Like the car, you have an engine, but what do we build around that engine,
Yeah, yeah.
right? So is that kind of the idea that you're talking about? Like,
There's a bunch of ideas that we're talking about and experimenting with and doing research on. So there's another idea. This scientist named Grebenikov came up with this idea that, beetle wings actually, the top layer is made of a different material than the wing itself, and they're actually metamaterials. Because the chitin in the beetle wing is actually is a metamaterial. It
wow,
can actually, it's made of pure organic materials like hydrocarbons and stuff, and arranged on because of the nanostructure in which it's arranged, you can get it to look, the wings look clear, right? The shell
yeah,
can look gold, it can look metallic, it can look silver, it can look like copper, it can look like pure metal and reflect light in the same way that a metal would, but it's made of the
wow.
same stuff as the wings, which are clear, but then they're slightly different.
Like, how is that possible? Like,
Yeah, and
that's
then
crazy.
then the triboelectric constants of the two materials are on opposite sides of the scale. So triboelectric effect is what happens when you rub a balloon on your cat, right?
Yeah. Okay.
You rub a balloon on your head and then you stick it to the ceiling, right? So your hair acts as the thing that steals the electrons because there's lots of things to take. There's lots of strands of hair, so like tens of thousands of strands of hair rubbing against the surface of that balloon, and it's taking all the electrons.
Got
And
it. Oh, okay.
or maybe is it depositing them? I think I think it's actually taking the electrons off of it, and then that's actually charging the balloon negatively or positively. I think it's actually it's reversed for some reason. They screw it all up positive, like the current flows in the opposite direction of from and all that. It's all messed up. But anyways, certain materials will steal electrons and certain materials will lose electrons,
Yeah.
so you have this triboelectric effect. And there's this whole idea that the beetle wings act as this asymmetric capacitor, which that's Biefeld-Brown effect. Actually, they think that you get a small amount of lift when you have these asymmetric capacitors working on things.
Okay.
That's this whole idea that maybe beetles have a little bit of extra propulsion in them, and other insects might use this sort of effect too for
That's
propulsion.
kind of interesting.
Um,
That's cool. That's
well,
kind of
what
cool, actually, to think
you
about.
know that spiders can travel thousands of miles using electric current. It's called lofting. The spiders will
What?
wait till the right type of day with the right type of effects. So it's got to be like a real dry day with the right type of currents and stuff. So it has to
Yeah.
have air current, but it also depends on the electric charge. They noticed that they did these lofting spiders. They went and took like an egg sac of the spider and released it in a room and did the experiments with different electrostatics, and they proved that the spiders would loft with the electrostatic.
What do you mean
Um,
loft? Like fly through the air?
where they spin this web, and the web actually gets electrostatic, and it lifts them up, and they can actually the spiders can lift off.
What?
They fly miles. They find these things miles in the air, and they can travel thousands of miles using
What?
this
Dude,
electric currents and stuff.
that's the craziest. My God, that is absolutely nuts to think about.